Good morning. It's Tuesday the 15th, 10 a.m. here at Questtec. Welcome to episode 2 of the Questtec Tech Talk podcast. Our goal here is to create a place for conversations from leading experts in the field and share their experiences on level applications and solutions. We've got a special one today. We've got a guest in from Vector Controls and Automation Group, Chris Fournet. Chris has 31 years field experience and 25 years at a major refinery in Port Arthur, Texas. He specified, purchased, commissioned GWRs in the field from many leading manufacturers. He's currently the expert on the E&H GWR and associated equipment, and he's here to guide us on the do's and the do-nots of GWR so we can help you guys solve real-life problems in the field. So without further ado, Chris, thank you for joining us today.
Yeah, thank you for having me.
Great. We've also got Owais Arshad, who you remember from episode 1, who will be a freaking guest with us here. So today we're focusing on GWR as a solution. Here at Questtec, we provide GWR oftenly with bypass chambers in combination with mag gauges or in combination with other instrumentation that's going into the field. On this episode, we're specifically going to focus on refinery solutions. So refineries being the biggest piece of our business here at Questtec, it's something that we want to highlight and talk to Chris about real-life problems we see in the field, as well as some of the highlighting features of his product, and Owais is going to have some back and forth with him. So let's go ahead and get into it. So we've established that we're working within the refinery. Chris, who within the refinery handles the specification of GWRs most commonly?
I've seen it different at different facilities, but by and large, the big majority of it is the instrument guys will typically handle the instrument side of things, the guided wave radar, making sure it adheres to your specs. And then usually there'll be another group involved. They come with a pretty big variety of different names, but for the most part, they're called PEI. And it's basically pressure equipment integrity guys. And it's the guys that are in charge of the pressurized equipment. Those guys typically have a hand in helping spec out the chambers, your welding procedures, inspection reports, and all that kind of stuff. So it's kind of a joint venture between instrument and the pressure equipment guys.
Okay. Yeah, I think that lines up with what we see here at Questtec, and I think what the level industry sees. For us, when we don't involve something like GWR, they want to shove it off to mechanical in some cases. As soon as we introduce something like a GWR or transmitter, we're right back to instrumentation. Reliability, I think in a lot of cases, maybe kind of correlates with that PEI as far as, piping specs, welding requirements, things like that, all things we're very well versed in.
Yeah, I definitely see PEIs getting involved with mag gauges a lot more nowadays. So.
Okay, good. So what we've been able to establish is for our reps, as we walk into a refinery, there is a direct correlation between going after the mag gauge product as well as GWRs in combination, typically with the instrument group. I think personally, I see the planners getting involved, on the initial level, getting a work order from the field saying either we have a problem or, hey, it's time to look at replacing outside of a turnaround or things like that. On that same note, do you see the need for, during the turnarounds or outages, for you guys to come in and either inspect what's currently in the field, or is that a time where you're seeing a lot of GWR specification as well?
Yes, absolutely. During a turnaround or downtime is a very good time for us to go in there and kind of analyze what the customer has, take inventory, and then from there, make some solid recommendations to improve reliability and accuracy.
Perfect. Yeah, that lines up perfectly with our philosophy as well. It's a time to go in and inspect, take an inventory in the field, so to speak. Personnel is constantly changing. People don't know what they have, what they're after. So great time for us. And what that boils down to, it works well in combination with what we do in the field with our reps to go in and add GWR as a solution. So moving into, once we're in the refinery and we're working through, let's say, service calls, not to focus so much on the service aspect of it, but what would you say are the top few issues you see? And it doesn't necessarily have to be an issue with the GWR, but it might be something that the plant needs to help the GWR be as accurate as possible, which is something that we see on our end with mag gauges and transmitters, especially when you're dealing with electronics.
Yeah. So probably the number one thing that I see is improper setup. Inside of a guided wave radar's head is approximately 262 parameters. And out of those 262 parameters, there is a bunch of things that can be adjusted to make the transmitter do certain things. And the majority of the stuff that I see in regards to guided wave radar is improper setup. There's a setting or two that was improperly adjusted, and it's making the radar do something that it should not. That is far and large, that is the number one thing that I see.
With the transmitters I generally deal with, I see a lot of noise effects. Does the GWR come across those problems as well? Field noise?
Yes. So if proper setup is applied, then a guided wave radar, especially if we're talking about refineries, steam applications, stuff of that nature, proper setup encompasses probably over 80% of the service calls that I receive has to do with improper setup.
Yeah, we've kept it very simple here. Well, with regards to GWRs, I mean, we do a basic a range test. We set it up for range, and we simulate level at those points, and we do a five point basic test here to make sure it's relatively accurate before it leaves here. Is there other things that we should be taking into account on the refinery level with settings? Because I'm gonna be honest, these radars have been relatively trouble free.
Yes,
and very simple.
That is very correct. And if the correct parameters are adjusted, these instruments are pretty much problem free. I very, very rarely see an application where if the transmitter has the correct settings in it, that it acts improperly. Very, very seldom. Normally, it's something that has to do with the type of installation. So whenever you're setting up a guided wave radar, I was talking about those 260 parameters that are in there. If you go through the commission wizard, it basically takes those 260 parameters and it puts about 4 or 5 of them in a bucket. And those 4 or 5 are the most important parameters. And typically people overlook stuff like the application type, such as, is this thing mounted in a bypass chamber? Is it mounted in a tank? All of these questions set thresholds in the background. It's not just conversation pieces. There's actually parameters that are being adjusted, and typically it's something like that. Usually they don't have, typically whenever you're going to be doing this, you're going to be installing it in a bypass chamber, and they typically don't have the bypass chamber as the tank type selected
as the default.
Right.
Okay. So you mentioned there's 4 parameters. Would you happen to know those 4 basic things that you're typically interested in?
So if you use the Anderson-Hauser commission wizards, typically you're going to get stuff like tank type. What type of application is this in? Is it is it inside a tank? Is it in a bypass chamber, a stilling well? If so, how big is that bypass chamber or stilling well? That is a very, very common overlooked question that's asked. Essentially, if you have a guided wave radar in an open tank, for example, and you had Superman X-ray vision, and you could physically see the electromagnetic pulse being emitted. It's about 16 inches in diameter. So kind of think of a football traveling up and down the rod. That's our footprint. Okay. So if you put this thing inside the bypass chamber, obviously that 16-inch diameter is being condensed into a 2-inch, 3-inch, 4-inch chamber. The radar needs to know that, and the reason it needs to know that is because there's thresholds that are set in the background to tell the radar, hey, you don't have 16-inch field of view, you have a 3-inch field of view, for example. And it just makes the thresholds work a whole lot more conducive to what your application is.
Is that also available through push buttons?
Yes, it is.
Okay.
Yes, all of the settings that can be done from the ENH software, or from anybody software for that matter, can be adjusted through the display as well. So you got the tank type, how fast does your level move? These are other questions. So we call that our focus window. So whenever you go through the commission wizard, that's another question. How fast does your level move? And it gives you specs. Typically the factory default is, does this application move either up or down greater than 40 inches in 1 minute? And if the answer is yes, you need to select that. And then, of course, you've got your calibration values, your empty distance, your full distance.
The basics.
Yeah, get the basics, and then it asks you about the dielectric. Essentially, whenever you're going through the software, it asks you, is this going to be a water-based material or is it something else?
Okay. Yeah.
And that magic number is 4. So, is your dielectric greater than or less than 4? Is basically what the software asks you.
Okay.
Cool. So you mentioned bypass chambers, and that's one of the things that we had a specific question about or wanted to bring up, because that's everything that we do here when we work with GWR. We're going out and telling our customers that a GWR in combination with a mag gauge is the perfect solution in a lot of ways, and it is. If you were specifying the bypass chamber, what size chamber and length would you recommend? And when I say length, it could be anything from overall centers to the dead space outside of those centers.
Right. Yeah. Excellent question. So whenever I'm speccing out a chamber, I basically take a look at how long it is. Okay. And I'll give an example. Let's say I've got an application and it's 20 feet from tap to tap. Okay. Mm-hmm. I probably would not elect to go with like a 2-inch chamber, for the fear of during that 20-foot span, I've got most likely it's going to be a cable and weight, and I don't want to take a chance of it hugging or touching one side of the chamber in that 20-foot span. Mm-hmm. All right, so I'll typically reserve my smaller chambers, my small diameter chambers, for smaller tap-to-tap applications. And then you got to take a look at plugging. Is your process very viscous? Is it liable to plug? If the answer is yes, then I'll typically elect to go with a little bit bigger diameter chamber. But there's just a few factors that I ask the customer before I start speccing out chambers, and your overall length, what type of process I'm going to have, stuff of that nature is kind of going to drive me to what size I eventually go with. Is it going to be a rod or is it going to be a cable and weight? All of these are questions that you really need to know.
Yeah. I think at Questtec, we've standardized on 3-inch chambers generally, mm-hmm. and it's worked really well for us.
Yes.
But, we do get that application where a customer would prefer a 2-inch.
Right.
And it's generally not a long unit.
Right.
Is ENH or you guys comfortable with a 2-inch chamber?
Absolutely.
Generally?
Absolutely. But again, typically if you're going to have 2-inch, try to keep that to your smaller tap-to-tap applications. Mm-hmm. But yes, 3-inch, 4-inch, those are all good applications. The transmitter will work good in either. I just need to tell it if it's in a 2-inch, 3-inch, or 4-inch.
So let's talk solid rod and flexible probe.
Yeah.
Now let's talk long length. We've heard of the limit of a radar by itself is mm-hmm. really long, right? So yes. Every now and then they want really long chambers for them as well.
Correct.
So understanding that the technology probably sees everything inside the chamber. Right. So
Correct.
Let's say we were to weld up a chamber, 2 pieces of pipe together, mm-hmm. to achieve our lengths that we want. Is it going to see that weld bead inside the chamber and be affected by it, or can it ignore it really?
It can absolutely ignore it, no questions asked. So basically we have a feature called mapping, and the purpose of mapping is to exclude any kind of false noise, such as weld slag, your top or bottom chambers, stuff like that. It's built to ignore that.
So like a socket weld, you'll have that small gap between the material. So the radar can see that gap, correct?
It can see it in most cases, but it's going to ignore it. And the reason it's able to ignore it is you have to take a look at, the comment that I had made a while ago about mm-hmm. our footprint, or if I had X-ray vision, mm-hmm. what would that look like? Okay. And if I've got let's say this is in a 3-inch chamber, mm-hmm. and I've got some weld slag at some kind of a seam that you had welded for your 2 pieces of pipe put together. That's only blocking a very, very small amount of my actual surface area that's inside the chamber, right? Mm-hmm. So because it's only blocking a small surface area, I still have a lot of other real estate from that chamber wall to the rod or cable.
Yeah.
So therefore, my level will typically give me a bigger echo. Okay. So I'm not too worried about having seams or any kind of discontinuations inside the radar chamber, because the radar does have algorithms to combat that.
Okay. So even if I were to confine it to a 2-inch chamber, possibly,
yes.
It could still help ignore it.
Yes, absolutely.
Cool.
Absolutely.
Have you ever been tried be driven into a smaller, even smaller than
Yes,
2 inch.
sometimes customers are trying to get by, with spending with spending as little money as possible, or they might have some kind of weight restrictions coming off their process vessel root valves that they can't hang a big chamber from.
Mm-hmm.
So they're trying to minimize weight. So I've seen both scenarios, and again, if I've got a 40-foot application and I've got a solid rod, having a 2-inch chamber is, it could potentially be problematic for me. As far as being closer to one side of the chamber, than the other, and in certain areas that might cause issues. Okay. But yes, the 2-inch chamber, I've done a bunch of applications on 2-inch chambers, and that's not an issue.
Cool.
Chris, when our customers or when our reps are looking at speccing these out, do we need to, a lot of times we have to go out and ask for the AML, the pipe specs, everything at that particular plant, especially when we're dealing with refineries. Is it important on our bypass chamber when we have a weld spec that we're going by that we translate that over to you guys?
Absolutely.
Okay.
Absolutely. And that's, and again, typically it's not going to be the instrument guys so much that take the ball and run with it there. It's going to be the PEI guys. Those guys are going to be very interested in all those specs that, regarding the chamber.
Yeah.
And you typically, whenever you get time to do the MOC, typically those PEI guys have to sign off on that chamber construction piece.
Okay.
Are there any tips or tricks to, selecting the radar with regards to versus competitors? I've seen options out there where a competitor will have a high temp option, but it's not necessarily high pressure. Mm-hmm. And they'll have a high pressure option, and it's not necessarily high temp. And maybe it's just my limited knowledge on E&H, but I feel like there's an offering of a high temp, high pressure option.
Yes.
But there's not one or the other.
Yeah, so typically when it comes to guided wave radars in refineries, you're typically going to go with probably 2 different models is really all you're going to go with.
Mm-hmm. And that's basically it for us.
Honestly. Yeah, and there's, you basically have our standard offering, just to give you some rough specs, is roughly going to be about 550 pounds of pressure and 380, I believe it is, degrees F.
Okay.
And then our high temp, high pressure goes up to 5,800 pounds, and it's good for 842 F. So it's going to be one of those 2. Now, just keep in mind that temperature and pressure are not the only things to really be on the lookout for. Mm-hmm. There are certain gases that can be corrosive to our low pressure, low temperature one. So our baseline guided wave is called the FMP51. Yeah. He has a certain kind of seal that is not really recommended for ammonia, chlorine, and steam. Okay. So steam is not the only gas you need to keep in mind. There's other gases that can cause problems, especially in the seals. Okay. And our FMP54, that is our high pressure, high temperature option. And that one has seals that are made for ammonia, chlorine, and specifically steam.
Okay. But that 54 is automatically high pressure, high temp.
Yes, it is.
Correct.
Yes, okay. It is.
But not one or the other.
Right.
Okay.
Right.
Chris, getting back to a little bit of the sales side as we get near the end, what do you see? One of the things that we focus on here is the type of technology that we replace in a lot of cases, whether it's we're upgrading side glass to mag gauges, or we're taking a mag gauge and bringing it back to a side glass, or we're implementing something like a GWR. For GWR specifically, what do you see it replacing more often than not within the refineries, whether it's old technology or just something that's not really working for a particular application where maybe GWR has proven successful?
Yeah, probably the number one thing that we replace is going to be some kind of density measurement, such as DP or capillary DP. Still today in this area, especially the ship channel area, of all the applications in a 50-mile radius of here, differential pressure still to this day consists of over 70% of all the applications out there.
Yeah, definitely.
So typically in refineries, you're going to see a lot of wet leg DP. You're going to see a lot of capillary DP. And that's the number one thing that we are replacing is going to be some kind of density measurement, DP or capillary DP.
Right, and I figured that that's the way you were going to go. And luckily, we've got you for another episode specific to steam, and I think that'll be a little bit of a topic because that's usually what I see on the boilers. And as we try to make recommendations as it pertains to boiler code and how that instrumentation functions, that's a lot of what we see.
Yeah. So the big thing that's the big thing about refineries is a lot of these plants have high pressure, high temperature hydrogen. All of them do. A lot of their instrumentation that they currently have is going to, if they're using some kind of density measurement such as DP or capillary, there's going to be a lot of applications at the hydrotreater, the hydrocracker, stuff of that nature. There's going to have gold-plated diaphragms. Gold-plated diaphragms is very, very common. It helps to slow down the ingress of the hydrogen, which can cause severe problems and premature failures. Having a guided wave in those applications does away with all of those problems. So I just want to throw that out there since we're on the refinery topic.
Yeah, absolutely. I think, being specific to refineries, with that being our biggest piece of business, that's where most of our reps have, a lot of their relationships, and that's where we push to be. I mentioned that we have you for a steam application or a podcast where we're going to talk specifically about power plants and even steam within the refineries. So there's a ton of opportunity for us and working with ENH as well. So last question, if you, and this is where you can highlight ENH versus, the rest of the field, if you could put on a billboard on 225 near the refinery about ENH, what would you say in a few words?
In a few words, I would say call your local level experts, and we have the absolute largest level grocery basket in the industry. There's nobody else that can come even close to the amount of different technologies that we offer. So it can be a one-stop shop for all of your level solutions.
That's perfect. I think that lines up really well with what we do here. When we say that we've got everything under one roof when it comes to level, indication, local level indication, we mean it. So that's perfect. Well, we appreciate it. I've got you back here again, so we'll get ready to get that one going as well. But thank you for the time.
Yeah, thank you for having me.